So very good morning to all. I, Professor Gambwa Yagnesh from Automobile Engineering Department. Welcome you to all. Welcome you to all on day 4, session 1 FDP on alternative fuels, sponsored by AICT Patel Academic, organized by Automobile and Mechanical Engineering Department, D Patel Institute of Technology. Let us start the session now. I would like to request Professor Samad Silas to introduce today's speaker, Dr. D Patel. Welcome, Samad.
Hello everybody, very good morning to all of you present over here for attending AICT ATAL FDP on alternate fuels. Myself Samar Shiller, faculty from Automobile Engineering of D Patel Institute of Technology. Heartily welcome each one of you present over here. Today we have among us Dr. Paresh D Patel sir for delivering a technical session on tribological assessment of CI engine fueled with biofuel. Dr. D Patel sir is presently working as Assistant Professor of Automobile Engineering at LD College of Engineering, Ahmedabad. Thank you, sir, for accepting our invitation and coming to deliver our technical session. Now, I would like to share brief resume of today's expert. Sir has obtained his PhD from Nirma University with the specialization in internal combustion engine. He is having 3 years of industrial experience and more than 15 years of teaching experience. He has published more than 15 articles in international and national level in the area of alternative fuels. He has also published a book in the area of engineering graphics for the first year engineering students. Sir has been involved additional charge as officer on special duty for the degree engineering and diploma to degree engineering admission at Admission Committee for Professional Courses ACPC at Ahmedabad. He has involved to lead a team of faculty members who have been deputed for degree engineering and diploma to degree admission for making entire admission process a successful one. He has successfully carried out administrative assignments like forming of draft rules for degree engineering, diploma to degree admissions, preparation of merit list, online counseling, etc., etc., etc. Now, not much wasting of time to start our technical session. I would like to invite Dr. Paresh D Patel sir to start the session. We'll learn a lot from this technical session. Paresh sir, please start.
Thank you, Professor, for introducing me. It's my pleasure to be a part of this. Is it audible to all?
Yes, sir. Yes, sir. It's audible.
Fine. Thank you, Professor, for introducing me. It's my pleasure to be a part of this FDP, specific in the emerging area like alternative fuel. As you said that, I have been associated with the government, state government, in some administrative work from last few years. We are dealing with the state admissions of all the engineering and private universities and private colleges throughout the year. But today I get a chance to deliver a talk with academicians. So as far as the area is concerned, in this FDP, it is designed such a way that it's cover all the area of optional fuel. For this, I must congratulate to all the concerns, institute, departments, coordinators, specifically head of the department, to organize such FDP, which is really a platform to understand the future scope in alternative fuel. And also it will be, I personally feel that it will be helpful for the person who are going to be for the research in the area of alternative fuel. If I've heard few sessions in the FDP, In the first session, if I quote Professor Gupta had well explained the alternative fuel, the need and scope. Along with this, respected Chaniwala sir, he has demonstrated emerging technology and many more. A day before yesterday, Professor Lakadawala said that tribological behavior in CA engine, specifically in CA engine, it is an extended work of my today's presentation. If we talk about yesterday's session, yesterday Dr. Deepse, he said that the policy and regulation were defined by the central government to regulate, to establish the alternative fuel. So along with this, it's my pleasure to listen to such eminent dignitaries. Now, if you talk about today's topic is specifically, it is my experience in the research area, what I've done in 2011. We feel today, the whole session, I'll share my presentation. Please wait. Is it visible? Hello? The screens are visible?
Yes, sir.
Thank you. Almost all the eminent speaker has said that today is a need for alternative fuel. We all are in search of alternative fuel because of today what I personally feel that, and everybody said that, the world is challenged with the twin crises of fossil fuel. This is what one is the reduction in the fossil fuel, and second that is environment degradation. This is what normally we are calling it is a greenhouse effect. This is unselective extraction and excessive consumption of fossil fuel have lead to decrease in underground based carbon capitals. Generally, आज हम सब ये जानते हैं कि fossil fuel जो हैं वो day to day reduction इसका हो रहा है, prices इसकी बढ़ रही हैं, environment degradation भी हो रहा है. तो now we have to find out an option with that we can use in transportation system. So that is what I feel that this is a hunt for an alternative fuel which ensure a pleasant correlation with sustainable growth. Again, I'll tell you that your alternative fuel should be sustainable growth, energy conservation, management, efficiency, and ecological protection has become extremely marked in the present scenario. This should not be such a way that it should be costly, too much costly. I agree that the alternative fuel is always promote better results in the exhaust, but it should not be too much costly, which are not bearable for the general people. Now, this is what the work going on alternative fuel. Generally, we have read the literatures, and on the literatures there is, as Professor Tipse said that yesterday, that there is a gaseous fuel and liquid fuel. So these are the few fuels on which the ample of research work is going on. But even though that is fact, ये सत्य है कि still we have not established the potentiality of alternative fuel in our transportation. So yeah, up to the mark. In few areas, the biodiesel has been used, but even though we have not established the potentiality of alternative fuel in our country. We have used LPG, we have used CNG, it is well established, but electric, government has promoting electric vehicle with giving some subsidies and etc. etc. But even though we are not up to the mark where we can reduce emissions, environment pollutions, and with that we can again achieve a better performance in CA engine. Feasibility for optional fuel. We are talking about the optional fuel, alternative fuel. So what are the feasibilities? That availability and renewability, emission effect on the environment and health, economy or cost, fuel and characteristics, adaptability to the existing engine, safety and infrastructure. Why I keep this part in our presentation? मुझे ये लगता है कि कोई भी फ्यूल आप जब इंट्रोड्यूस कर रहे हो, इसको आप चेक कर रहे हो ऑप्शनल फ्यूल के तौर पे, whether it is CI engine, whether it is SI engine, any engine, internal combustion engine for the transportation part. So we have to assess these all we have to check the feasibility of these all parts first, and then we can use this fuel for the long run test. Otherwise, there may be some problems in the future. For the short run test, there is no issue. I used to say that, मैं हमेशा ये कहता हूँ कि जिस तेल से दिया जलता है उससे इंजन चलता है, but it doesn't matter, it doesn't means कि हम उस ऑयल से इंजन को चलाएं. We have to check these all parts, and then we can introduce this fuel as an optional fuel. So for that one, I'll say till date, normally what we are doing, what we are measuring to establish the alternative fuel as with fossil fuel, we are observing with the properties of the optional fuel, performance of the vehicle, emissions of the vehicle. But most of the fuels are less damaging to the environment, as we all, and you all are aware about this. By using alternative fuels rather than fossil fuels, we are getting better results in emissions from the alternative fuels. But as far as the performance is concerned, I have reviewed so many articles, we are not achieving the performance up to the mark. So however, the technical feasibility is no longer questioned. But so now the focus is still towards the durability test to extend the period of running of engine fuel with alternative fuel. So we have to check the durability analysis to establish that fuel, any fuel. I'm not talking about the biofuel, I'm not talking about the hydrogen fuel or electric fuel. You use any fuel, but you have to establish, if you want to establish the potentiality of alternative fuel with fossil fuel, at least we have to check the durability test with that alternative fuels. For that, the life cycle analysis is introducing. Now, life cycle, LCA, generally we are calling it as LCA, life cycle analysis. Life cycle analysis, it means it is a long run test. We can say it is a long run test. Some reviewers said that it's an endurance test, it's a tribological analysis, it is a durability test. Any terminology you can use it, but how the LCA has been carried out, how we can implement this life cycle analysis in our transportation sectors. So if I say that it is basically process-based analysis, it is experiment-based analysis. Now, process-based analysis, if we say, so here we have to examine the environmental aspects, product aspects, the all stage of this throughout the life of the component, throughout the life of the system. We have to examine the environmental aspects and product aspects. I'll give you the best example for the process-based analysis. Normally, most of the colleges are participating in essay Baha competition. Now, what we are doing in essay Baha competition? In essay Baha competition this year, my institute has participated. We have we have designed the vehicle, all-terrain vehicle. We have manufactured the vehicle in our own campus. We participated in Indore at net trip. Next year, when we participate for the second time, so what we are doing, we disassemble the whole all-terrain vehicle. We use it. Those components which are in a condition to use it, we use it. Those which require to fine-tune, we tune up that component. Those which are not in a condition, we garbage it. So this is what the process-based analysis. Now, experiment-based analysis, that we have to examine the potentiality of any component of fuel with respect to the base data, with respect to the fossil fuel which we are using in IC engine. This engine test stand is a facility used to develop characters and test engines. Now, if you go through the process furthermore, as I said that essay Baha competition, it is an example to understand, friends. This is the basic example to understand that what happens during this part. So here we have manufactured any component, product, we distribute that part, we use it, then after some times, after the defined age on the basis of performance or application, after the application, we garbage that equipment, we garbage that vehicles. So this is what the end of life. Again, during that part, what are the component can be used, what are the component can be recycled. So we recycle that component, we disassemble it, and the material has been gone through the manufacturing plant, and then again that has been used for the product. This is what the whole cycle that we are following. This is the life cycle with the process point of view. As far as the performance and experiment is concerned, we move with the experiment point of view. Friends, here, this is what my experience from 2011. I've reviewed, I'm sharing today, friends, I'm sharing today my whole experience of life cycle analysis during my research. So here, in experimental point of view, if we see any engine which can be used for the transportation purpose, vehicle, it has to be find out this performance analysis. And then secondly, we have to check the addition of any oxygenated fuel, impact of addition of oxygenated fuel. Again, we have to check it that whether any engine parameter has been influenced on the performance and emission. So this is all one part of this. And normally ample of work has been done during this portion. I've seen so many articles, sample. If I search on the biodiesel in Science Direct elsewhere, I'll get hundreds of papers. But even though that is fact is, we have not established the biodiesel in a full fledged in our country. So again, there is some problem. So that we have to find out why we are lagging. So if I'll move with the life cycle durability analysis, in the durability analysis, there are two components which has to be checked. That is a rate of wear we have to identify, how much rate of wear occurs in the engine components, and what are the impact of the lubricating oil. So this can be done by the qualitative analysis and quantitative analysis. I think so. This slide has been shown by Professor Lakdawala. Professor Lakdawala has explained the tribological behavior of few different transgesterified oil. So what are the tribological behavior? It was the extended work after this life cycle analysis. This work has been done by Professor Sajin Chaurasia. So here in qualitative analysis, we carried out ferrography analysis, and second, there is a physical visualization. Life cycle analysis. In a life cycle analysis, we have to observe throughout the process, throughout the tenure, that what impact occurs on the engine components, whether by use of diesel engine, whether the use of biodiesel, whether the use of any biofuel, whether the use of any oxygenated fuels. And at the end of the day, end of the experiment, we have to conclude that by use of this fuel, the engine can be run in a better way. The engine can be, the component cannot be wear. The life of the component is this much of increase by use of this way. There is no doubt that in piston engine, in piston, in connecting rod, or in any engine assembly, by use of diesel or petrol, we are achieving 1 lakh kilometer life. And at the end of 1 lakh kilometer, we have to be, maybe there is, if it is required, then we have to replace the component. But by doing this life cycle analysis, we can conclude that, yeah, it can be increased by 20,000 kilometers more. I'll tell you one thing, always been, during the research, we always optimistic, we'll get positive results. मैंने भी जब ये research start किया था 2011, I was in an impression that I'll do the life cycle analysis. At that time, मेरा जो case study है, तब I have reviewed few articles of Professor Agrawal, IIT Kanpur, Professor L.M. Das from IIT Delhi. They have done some work in life cycle analysis. So I reviewed and then I started my work. I was not knowing what impact will, what benefit I will get, the rate of wear will be increased or decreased, that I was not knowing. But step by step, I'll done the experiment and I'll achieving better results. But always been, it is not possible that I'll get the better results. If someone will change the oil and he will get better results compared with this experiment. So here, experiment point of view, if you see the background, this is what pollution and planning board, this suggests that if I talk about the effect of this emission with only transportation sector, I'm talking about only transportation sector. So in transportation sector, this 80% emission has been omitted in the environment by the road transportation. Very few, 13, 7 and 1%, it is by the rail, sea and air. So now we have to think something more to minimize this emission in environment, which is omitted in road by the road transportation. So now how we can reduce this emission? So now what we have to think it. So if you see the vehicular pollution control, there is some question, it occurs in my mind that what we have done till date, the actions. So government is, again, I'll say that there is some regulation, there is some policies to establish the biofuel as with the alternative fuels. The fact is, again, I say that we have not established biodiesel with the main fuel. There is a lots of work is done, there is no doubt, friends. But Again, we have not established this fuel with the mainstream. What we achieved till date. So again, there are lots of work is going on to establish this optional fuel in CI engine, in SI engine. If I talk about Gujarat, if I talk about in Gujarat, to minimize this pollution in Ahmedabad, to minimize this pollution, government is introducing this bus rapid transit system, public transport system. So this is what one, I'll let you know later on. This is one parameter that we have to be develop a public transport system in a way that everybody can get it and everybody can use it. Are we on the right track? Again, there is a question that yes, I'm not in a position that it can be established with the mainstream or not. But definitely, yes, we are hopeful that we will definitely, state government, central government, policies, regulation, they are working day and night, and they will, in a short period, we will establish any one fuel with a mainstream. Again, the technological intervention is required. How we can minimize these pollutions? So again, we have to improve the fuel qualities. To improve the fuel qualities, we are using CNG as an optional fuel. Progressive emission norms, again, there is an improvement in the Bharat stage 4.6. Alternative cleaner fuel, as I said, CNG is, again, there is a almost zero emission vehicle. As I said, that improvement in the public transport system in Gujarat, so many cities we are introducing this rapid bus transit system, BRTS. It has a special corridor. Government has made a special corridor for the public transport system. So there should not be any obstacles. There should not be any traffic for that. In Gujarat, there are so many cities. We are introducing this bus rapid transit system. And lastly, I said that engine components, that is material compatibility, has to be verified. So these all parts has to be, in keeping this mind, these all parts, I've started this case study for life cycle analysis in 2011. At that time, I was not in impression that which fuel I'll use, which one is a more impact in the combustion area, in performance area, in emission area. But I've started with biofuel. It is a non-edible oil, and literature suggests that use the concentration of biodiesel up to 30%. So I would restrict myself up to 30%. Now the matter of addition of additives as an oxygenated fuel, I'll let you know why we are using additives. So I'll show you in the graph later on. So what happens during my performance and literature support, almost in biodiesel, we all are aware that during the biodiesel, performance is almost same. Brake thermal efficiency, consumption, fuel consumption, these all are almost same. But as far as the emission is concerned, in emission part, these hydrocarbons, carbon monoxide, carbon dioxide, that is okay. It's fine that it is reduced up to the mark, but NOx emission is increased. And this is why it happens, because in biodiesel, there is a oxygen content is 11% by weight. So there is a possibility that NOx emission, and even in environment, there is a nitrogen gas. So during the combustion, there is oxide of nitrogen is increased. Again, it has a correlation with the exhaust gas temperature. So definitely it will be increased. But how we can minimize that part? Because we have to work with our Bharat stage norms. We have to keep in mind the Euro norms, Euro 4 norms. So with that line, we plan it, and we have hypothetically planned it that can we use any additives, and we further go ahead. So during that part, one idea come in our mind that we use, and again 2-3 literature they say that you can use dimethyl ether, you can use diethyl ether, any, but it should be up to the 5 in the step of 1% up to the 5%. We cannot use 15% or 20% additives. So with that part, we have used additives, and then we have performed our experimentation. So in life cycle of any automobile with biofuel, normally we carried out these 4 analyses: property analysis, performance analysis of CI engine, fuel with biofuel, alternative fuel, engine parameter analysis with respect to the engine parameter, long run analysis. Now this long run D component is a key part of this presentation, that normally we are dealing with ample of work is done on this A, B and C. But in D part, what we have to do, that we'll see today. Basically, I've reviewed so many articles, I have reviewed PhD thesis, I have reviewed MTech thesis, and I found that 80% people, they are doing some research in the area of alternative fuel, specifically in the biodiesel. And in biodiesel, what they observe is, I have used acarangia oil, I have used jatropha oil, I have used rapeseed oil, cottonseed oil, any oil. Esterified, I'm talking about esterified oil. I use esterified oil, and then they have measured the performance, they have measured the emission with the use of any 5-gas, 4-gas analyzer, and then they conclude that, yeah, emission is reduced. But is it sufficient? Because what happens throughout the country from north to south, the demographically, if you see, the condition, environment condition is different. If I do the performance in the north part, Kashmir, Uttarakhand, Himachal, and if I do the research part in the area of eastern portion or southern portion, so there is a different values I will get. So highest standard this suggests that during the performance, first of all, I'll suggest that during the performance analysis, we should keep the highest standard part 10,000 performance analysis, and on the base of that performance analysis, we should carry out the performance. Because what happens, this highest standard suggests that the site condition and standard temperature pressures. So on the basis of that site condition, we have to calculate the corrected factor, and we have to multiply this corrected factor with these three: corrected factor for engine power, corrected factor for bed specific fuel consumption, and corrected factor for the thermal efficiency. Then we can conclude that, yeah, any part, we will get the performance analysis with this respect. Here, during my analysis, initially, as I said, that we have selected the test fuel, we have selected the additives, we have prepared the blend. Again, this third component, preparation of blend with diesel fuel. It is the most important portion for the analysis of properties for the performance part. When you add anything in the diesel fuel with fossil fuels, it may be your biodiesel, it may be your oxygenated fuel, diethyl ether, dimethyl ether, it will vaporize. So you should have to sterilize in such a way that immediately you should check the properties and immediately you should use for the performance. You should not keep it for the day and then you use it. You will not get the better result. This is what again we have observed. And to establish that part, number of times statistically result we have been checked and then we conclude. This should be properly blend. Again, the measurement of fuel property, engine performance, combustion and combustion characteristics as per the IS 10000. Now the selection part, after selection, we have selected diesel as a base fuel, biodiesel derived from unadded oil as biofuel, and bioadditives, that is diethyl ether. Again, there is a question that why use diethyl ether? There may be a possibility that you can use dimethyl ether. There are 3-4 additives are available. You can replace the diethyl ether and you can further go ahead for this analysis. You will get some better results. There may be possibilities. But biodiesel, that is up to the 30% in the step of 5%. Bioadditives up to 5% in the step of 1%. And diesel blends. Load condition that we have kept in mind, that is initially that is no load, then partial load condition, then 50% load, 75% load, and 100% load. Compression ratio, that is we have not changed yet. In the further study, we have changed it, but here, what the manufacturer suggests, we kept the compression ratio 18, and we have further go for the analysis. Then I say the measurement of properties. So here in measurement of properties, we have checked so many properties, but two key properties, that is density and calorific value. In density, we have used the ASTM standard. It is a standard, ASTM standard, that we have assessed, and bomb calorimeter has been used with the standard, that is the ASTM D240. So these are the standards. It is well defined. These are the standards we have used, and then we have calculated the density and calorific value. But keep in mind that initially we have measured the properties for the diesel and biodiesel. Then we are not achieving, so we have add the additives, and then we have measured these properties with diesel, biodiesel, and oxygenated additives. So here the property which we received is, it is really impressive that this is the percentage of biodiesel, concentration of biodiesel that been used. This point is 100% biodiesel, this point is 100% diesel, this is the density, this is the calorific value in megajoule per kg. So as the gradually the concentration of this biodiesel is increased, this density, density of this fuel is increased. Density of fuel is gradually increased. And same way, the calorific value has been reduced gradually. At the 100%, almost it is near to this one. There is a drastic change for the 100. That's why we are not using 100% biodiesel in C engine. So here, there is a drastic change of calorific value between the 100% diesel and 100% biodiesel. After addition of diethyl ether, so here what we observe that 20% almost here, this 20% and here this 20%. So here the 20%, the calorific value is almost nearer to diesel value. So 20% we kept in mind that we can use blend up to 20%. And again, by addition of this, the calorific value of diesel and diethyl is what we achieved is 12% and 30% lower than conventional fuel respectively. The density of biodiesel is 7% higher, while the diethyl ether is 14% lower than conventional diesel. Hence, for the same performance, the engine will consume more fuel when fuel with blends of biodiesel as compared to the diesel. Moreover, if I say that, what we observe that in biodiesel and diethyl ether have a higher cetane number and oxygen content as compared to the diesel, which may lead to a better combustion in the engine. That's why it is hypothetically we have started our performance, we have started our experiment with this thought that hypothetically we will achieve a better combustion by use of this oxygenated fuel. And we further go for the performance. This is we see a variable compression ratio test rig where we can change the compression ratio, where we can change the injection timing, where we can change the injection pressure. So we have used a variable compression ratio test rig for the CA engine. These are the different temperatures has been observed throughout the experimentation. This is temperature T1, that is inlet water temperature, outlet water temperature, inlet calorimeter temperature, outlet calorimeter temperature. These all are in degree centigrade. Exhaust gas temperature before the calorimeter, exhaust gas temperature after the calorimeter. This is on the base of this exhaust gas temperature. Again, it has a correlation with your NOx. So we have observed these all temperatures throughout the experiment. It is a tidy process. I'll tell you, let you know. लाइफ साइकिल एनालिसिस ये एक ऐसी प्रोसेस है जिसके अंदर आपका इट्स नॉट अ रॉकेट साइंस, बट इसके अंदर आपका कंसंट्रेशन इतना होना चाहिए कि थ्रू आउट द प्रोसेस, आई टेल यू, थ्रू आउट द प्रोसेस इसमें आपका मॉनिटरिंग, कांस्टेंट मॉनिटरिंग इज रिक्वायर्ड. I say the performance of biodiesel on engine, still I am not talking about the additives. It is on the base of performance. I have not used additives till time. So on the performance, this is what the different blend we have prepared. B5, that is a blend of 5% biodiesel, 10%, 15%, 20%, 25%, and 30%. So biodiesel is having a low calorific value and high density as compared to the diesel. As I said earlier, at the same time, biodiesel contains oxygen 11% by weight. Due to that, we feel that the lower calorific value, the actual fuel consumption, this is AMF, is found to be higher with all blends as compared to the diesel fuel, although it is increased marginally, not up to that remarkable part, but marginally it is increased. When we observe the brake specific fuel consumption in kg per kilowatt hour, brake specific energy consumption and brake thermal efficiency, it is observed that as concentration of biodiesel, it increased marginally. Concentration of biodiesel is increased. This BSFC and BSEC is increased, while brake thermal efficiency is marginally decreased. As this observation has been done on the full load conditions almost. So during that, again we have observed that this is maybe due to the fact that the heating value of blending of diesel biodiesel blends are lower, so more fuel is required to produce the same amount of energy. That's why there may be a possibility that this is reduced marginally. But the variation in brake thermal efficiency is also, as I said, that it is marginally due to the complete combustion achieved, that is in the presence of oxygen. As I said, that in biodiesel there is a oxygen content is higher. So looking to the result, it can be concluded that the brake thermal efficiency for the B20 blend is found 0.5 to 1% less as compared to the diesel fuel, while BSFC and BSEC is found 7 to 10% higher. So looking to this observation, we have restricted ourselves for the 20% biodiesel to be used for the further experimentation. As I said that in the exhaust emission, it is almost all the literature support that in emission, biodiesel is a very fruitful, very useful. Here we have observed 4 pollutants: carbon monoxide, carbon dioxide, gram per kilowatt hour, oxides of nitrogen and hydrocarbons. This horizontal line, it shows the Euro norms, Euro 4 norms. So here, almost in these three graphs, we have achieved this exhaust, control these emissions, CO emissions, HC emissions, CO2 emissions with respect to the exhaust gas, sorry, European Union. But as far as the NOx is concerned, in NOx, we have not achieved this exhaust emission. It is comparatively higher by use of biodiesel. So that's why we have planned to use oxygenated fuel to achieve this NOx emission with respect to the European Union or standard, with reference to Bharat State Standard or European Union. I'll tell you one thing, one more. I have referred few articles. In the few articles, almost 70% articles, they suggest that the NOx emission is increased by use of biodiesel. But in few articles, I've seen that it is reduced NOx emission. Then I have read the whole component, whole article, and then we see that again, as I said, demographical part of the country, the soil properties also play a vital role to reduction in the NOx emission, as this suggests that the soil property of this, where this crop is planted. So again, it plays a key role for the reduction of NOx. I have not gone furthermore, but I have seen that in some article, someone says that, sir, in few biodiesel it is reduced. But here, in almost biodiesel, they suggest that the NOx emission is higher. So again, this has to be rectified. So to rectify this part, as I said earlier, hypothetically, we have planned on the base of literature to add the oxygenated additives in the engine emission and performance. So with that aspects, addition of additives on engine performance, we achieve a better results. We achieve a better results, and this fuel consumption we have achieved always been. If I say earlier, if I say here in the part load condition, if someone says that in the part load condition, the emission is always higher, it is obvious that it is higher because the fuel air ratio is very lean due to the incomplete combustion. During the part load condition, always been the emission is higher. But the observation should be made on the full load condition during the dynamic condition, full load condition. So on the full load condition, all the emission has been controlled. It is reduced. Friends, as I said, by use of oxygenated fuel bioadditives, we achieved good results in form of performance as well as in form of emissions. Here in emissions, specifically, if I talk about the exhaust part, by use of this one, we achieved this emission. It is with respect to the Euro norms. So the effect of diethylethran emission of specifically on the oxides of nitrogen, as cetane number of diethyl is quite higher than the B20 blend, it exhibits a shorter delay period and results in better combustion. Therefore, it is envisaged that the higher oxygen content and cetane number of the blend may lead to a lower NOx emission. But with the 4% of diethyl ether, NOx emission found to be reduced up to 25% during our performance, during our experimentation. That's why we have used this 4% bioadditives. We further decided that we will move with the addition of 4% bioadditives in 20% blend with the fossil fuel, and we will carry out our life cycle analysis on the base of that part only. So it is really interesting that if we will not achieve this NOx emission with respect to diethyl ether, then maybe we have to replace our bioadditives and we have to go furthermore for the experimentation. But here we achieved, so we move furthermore with the 4% of additives, 20% of biodiesel, and 76% of fossil fuel. Again, if you see the combustion characteristics, so here in the combustion characteristics, friend, I have demonstrated this 4 part, that is P theta diagram. This is net heat release pattern. This is delay period with maximum pressure and rate of pressure, and theta pressure maximum. So maximum pressure is found to be increased with the gradual addition of diethyl, although the variation is marginal. If you see, this is a 0% additives, this is a B20 blend, 1% additives, 2, 3, 4, 5% of additives. So it is a marginally, it is variation. This may be due to the enrichment in premix combustion, as the peak pressure may depend on the combustion rate in the initial stage. So it is a marginally because of the enrichment in the premix combustion. But interesting is that by addition of diethyl ether, the peak pressure achieved nearer to TDC. This peak pressure is nearer to TDC, and it is examined with 20% blend. It was observed 11 degree before after top dead center, while addition of 4% diethyl ether we received it is nearer to TDC, that is 9.5 degree. So we feel that it is a good symbol for the better combustion, normal combustion. So again, it support for the better combustion. This bioadditives is support that better combustion in a CI engine. On the basis of this part, we have published one article. It is available on the experimental investigation on reduction of NOx emission of compression ignition engine fuel with biodiesel and diethyl ether. It is in the International Journal of Global Warming in Science 2016 that we have published. It is available on the open sources. Now, first portion, this work has been done by so many fellows, there is no doubt. Now the second person, the engine manufacturer has given some configuration that this is the engine injection pressure, injection timing, and this is what the compression ratio is good for this fossil fuel diesel engine. Now we are replacing this fuel. So we have to assess, we have to play with some engine parameters, we have to change the configuration of engine parameters, and then we have to examine. This is what we feel. On that objectives, we go for the study with the engine parameter analysis with respect to the engine performance. Initially, we have identified this 20% biodiesel, 4% additives, and 76% diesel fossil fuel. But with the same engine parameter, by replacing the engine parameter, are we achieving few more results? So with that objective, we have been carried out this parametric optimization. So in the parametric optimization, keep in mind there are a number of parameters are available. Our response as performance, so brake thermal efficiency, brake power, brake specific fuel consumption. But this engine, I have used 3 engine parameters, that is injection pressure, compression ratio, injection timing. But again, I'll tell you, there are another number of parameters we can use, and we can go for the more for the research. Engine tip, nozzle tip, nozzle spray angle, nozzle pattern, spray pattern, then blend ratio, then jacket temperature, inlet temperature, engine load, spray holes, engine spray holes, diameter of the spray holes. These all are, again, 2 students are doing research under me with these nasal spray holes and nasal spray angles. By changing these nozzle spray angles, are we achieving some more results in the biofuel, or we are promoting a better combustion? So we are studying on that part. But here we have taken this injection pressure, compression ratio, and injection timing. These are the 3 different parameters we have used, and we move furthermore with this one. So by use of these 3 different parameters, we have optimized. We have used response surface method as a technique, and on the response surface method, we have used the response as a brake thermal efficiency, and the input parameter is the compression ratio, injection timing, and injection pressure. Now, injection timing and injection pressure, the range of injection timing and range of injection pressure, it is 16 degree, compression ratio is 16 to 18. Again, there is a question. It is a questionable that why it is not 20, why it is not 22. But again, this table, it is with respect to the literature support, we have keep in this mind that 18 to 22 bar pressure we have been examined, 15 to 20 degree crank angle before top dead center, and compression ratio 16 to 18. It is a general range, so we have keep this general range for this experimentation. And with that aspects, we have prepared the test matrix. This portion has been completed. If you see this plan, the supplementary fuel, that is B5, B10, B15, B20, B25, B30. The concentration of bioadditives is 1%, 2%, 3%, 4%, 5%. The engine load condition from part load to full load condition. Statistical, to get the statistical analysis, we have performed the experiment by 3 times. So total reading, that is experimentation for the one particular blend of B5 with 0 additives, 15 readings. And on the base of that, we optimize one blend, that is B20 biodiesel, 4% additives and 76% fossil fuel. Now with this further study, that is parametric optimization, that is 16, 17, 18 compression ratio, 20 degree before TDC, 25 degree before TDC, 25 degree before TDC, with these 3 different value of injection pressure. So we have prepared a design of experiment with respect to the response surface method, and we have to conclude a one configuration. The blend is optimized. Now the engine parameter has to be optimized. And then on the optimized engine parameter, we have to perform the life cycle analysis. So with the response surface method, if you see the interactive effect of compression ratio, injection pressure and injection timing. So here if you see this first plot, that is brake thermal efficiency, this injection pressure and injection timing. If we increase the constant, if we increase the compression ratio gradually, and if we increase this injection pressure gradually, the brake thermal efficiency is gradually increased by both the way. This is again because of the pressure is during the high pressure, it promotes the combustion, normal combustion. So there may be it promotes the better brake thermal efficiency. But at the same time, we are not achieving that this gradually increase of injection timing. The brake thermal efficiency is gradually increased, but at some part of point, it is then started for reduction. So you can say that advancement of compression ratio and advancement of injection pressure is a healthy condition for the engine, but excessive advancement of injection timing, it is not a healthy condition for this combustion engine. So on that base, we optimize the range. This is the optimization of the level, that is 18 compression ratio, 220 injection pressure and 20 injection timing before. So with this, the predicted value which is given by this software response surface method is 28 brake thermal efficiency percentage, and experimental value is this. So we have been carried out the long-term analysis with the optimized blend and optimized engine parameter. And with that part, same part has been, again, as I said, that we have been published in the Taylor and Francis in Biofuel Journal, that is box-Mencken-based response surface methodology for optimization of operational parameter of combustion engine fuel with blend of diesel and diethyl ether. Again, it is available on the open source. Now the key part, that is the life cycle analysis of CI engine using optimized blend. So more focus on wear and tear. We have to identify the rate of wear by use of this fuel. What the rate of wear we will achieve, whether it is in the positive way, whether it is in the negative way. That performance we get the positive way, emission we get the positive way, combustion is support that, yes, we can go ahead for this. So on that aspects, with that objective, we further life cycle analysis. Now diesel fuel, as I said, this is 20%, 76, 20 and 4% additives. This is what my blend, this is what my optimized parameter. And then we started our life cycle analysis. Now life cycle analysis, I'll tell you first, the life cycle analysis, it has a component, it has a few stages for the life cycle analysis. First stage is we have to go with the preliminary test. हमने इंजन के पैरामीटर को आइडेंटिफाई कर लिए, हमने सुटेबल ब्लेंड को आइडेंटिफाई कर लिए, अब हम इसको लॉन्ग रन टेस्ट के लिए, शॉर्ट रन के लिए तो एवरीबडी इज डूइंग शॉर्ट रन, सो नाउ लॉन्ग रन टेस्ट, ड्यूरेबिलिटी टेस्ट के लिए व्हाट वी हैव टू डू. सो हियर the preliminary run for the test of both the engine. Now one is we have to propose the comparative analysis for the rate of wear for the life cycle analysis. One engine we kept it for exclusive for the diesel, second engine we kept it exclusive for the B20A4 plant. Now we have prepared the comparative study. So initially we have run both the engine with preliminary run for 49 hours. It is a 7 cycles for the 7 hours. 7 days, 7 cycles for the 7 hours. Per day, we have to run the engine with 7 hours. And we have to observe the condition of the engine. Is there any damages or there or anything else? So we have to observe that part. Then, at the same time, initially, we have measured the parts of engines before the long run test. At that part, we have disassembled these all parts and we have take the dimension of engine parts. We have take the photographs, physical visualization of the engine parts. This engine assembly, हमने engine assembly जो है इसमें कुछ component, piston assembly, connecting rod, crankshaft, valves, इसके pieces को cut करके हमने इसके this component elementary analysis भी करवाया, क्योंकि at least we should aware कि हमें ये पता होना चाहिए कि कौन से component में कौन सा material बना हुआ है. अगर वो कंपोनेंट का वो मटेरियल अगर मुझे लूब ऑयल के अंदर डेब्रिसिस मेटल में मिलता है तो वी कैन से दैट दिस कंपोनेंट इज मे बी वियर टिल डेट. सपोज आई चूज brass material or any part I received in a sample of lube oil as the debris metal. I cannot say that the piston is crankshaft is wear, or this connecting rod assembly is wear, or this whole engine piston assembly is wear. Again, for that one, we carried out the surface roughness analysis for this particular that part, images of that part, scanning electron microscope of that part, and then we conclude that yes, this component we received in the sample, so there is a possibility that this component is wear. So this is what the second part. Then photography of vital part of engine during the long run term of analysis. Then we have run the engine for 512 hours, both the engine parallel. We have run it for the 512 hours. It is a 32 cycles or 16 hours. Every day morning 7 o'clock we have to start the engine. We have to monitor the engine throughout the day, and at 11 o'clock we have to shut down that engine. So it is a 32 days constantly we have to monitor both the engine run with the diesel fuel. It is run with the B20A4 plant, and constantly we have monitored, and we took the performance and emission constantly, and then at the end of this 32 cycles we prepared a comparative analysis. During that, as I said, that flue gas analysis also be monitored. This again I'll tell you, it is a very tidy process. ये प्रोसेस के अंदर एवरी डे मॉर्निंग 7 o'clock टू नाइट 11 o'clock, इसको पूरा, इसमें ऐसा भी हो सकता है कि सम पार्ट यू विल गेट सम डैमेजेस. So if it is minor damages, the higher standard suggests that minor damages can be solved out and you can start it again. But if there is a major damages, there is a possibilities of connecting rod, crankshaft damages or piston assembly damages. So at that time you have to restart this whole experimentation again. But by the grace of God, we have not received any such major damages, and we have completed this 32 cycles of 16 hours per day. After completing this part, again, as I said, this earlier process has been carried out second time, that photography of the vital parts of engine. Is there oxidation? Is there carbon deposition? Is there oxidation? This all has been observed. Measurement has been taken, weight has been taken, and finally surface roughness and microscopic image analysis has been taken. So this is what this all part is. It's stages of life cycle analysis. This is again, it is with respect to the engine components. Now wear is occur, always wear is occur with fossil fuel, wear is occur with any parts. So where the debris metal is collected. So debris metal that is collected in the engine sum. So at every 128 hours, every 128 hours, we take a 50 ml of oil sample. Again, please take care that every morning when you start the engine at 7 o'clock, before that you should have to take a 50 mm sample, क्योंकि ये जो भी debris metal आप रात को 11 बजे engine को बंद करते हैं, throughout the day वो engine चलाएं, so रात को वो पूरा sun में bottom side पे आ जाएगा. So at that time you have to take a 50 ml of oil sample, and इसको आपको ferrography and atomic spectroscopy करवाना है, double AS करवाना है. So उससे आपको पता चलेगा कि कौन सा component है, कौन सा element है, इसका कितना percentage wear हुआ है, और कितनी उसकी size है wear की. So that has been carried out every 120 hours. For diesel fuel, we have collected 4 samples. For B20A4, we have collected 4 samples. At the same time, when you take a 50 ml sample, same you have to top up 50 ml in the lubricating oil. Again, biodiesel is it's property of lubricating oil, as literature says that biodiesel is a lubricating oil. So again, every time, every end of the cycle, you have to be every 128 hours, you have to take a 50 ml sample. Apart from that, I'll tell you, apart from that, we have not demonstrated here, but I have taken the reading of vibration also. During the life cycle, is there any vibration occurs? So for the vibration analysis, I had used FFT analyzer. And FFT analyzer with identified 3 points. One is a base, second is a crankcase, and third is a cylinder head. At this 3 part, we have checked the frequencies, natural frequencies, and we have measured that at every day once. We have checked the frequency analysis so that we can say that yes, there is a vibration occurs or not, because ultimately the vibration is also a part which affect on the life cycle. This is not demonstrated here, but that also has been carried out. Now, how this preliminary test and long run test has to be taken. So as I said, this long run test for the preliminary test, ये ऐसे नहीं है कि I have started the engine and then it will work on it will run on any load. there is a specific load condition is defined in standards. So at initially 25% load, 1.5 hours. This is what this portion is a preliminary run. This is what the 7 hours, 7 days, 49 hours exercise. So 25% load has been for the 1.5 hours, then 50% half load condition, 2 hours, then 75% load, 1.5 hours, and 100% load for the 2 hours. So this is a bifurcation for 7 hours. So we have to run the engine with these aspects, and we have to constantly monitor the engine. Again, for the actual load condition, when you run it for the 512 hours, 512 hours, every day I have to run the engine for the 16 hours. So this is the bifurcation of 16 hours. Initially for the warm-up condition, 4 hours, that is with the full load condition, then 50 load condition, 1 hour for the overload condition, then half hour for the idling condition, no load condition, again full load condition, again 3.5 with the half load condition. So with this loading condition, we have to run the engine for this 32 days. Both the engine we have to run the 32 days. This is what now elementary analysis. Now elementary analysis, this basically we say that why this need of life cycle is required. So the main need for the life cycle analysis of CI engine is a combustion associated property of plant oil are slightly like to be mineral diesel, but for the pure plant oil is a mixture which diesel may long lasting problem in CI engine. It may be creating long lasting problems. Such difficulties should not be arised if I go with the short run analysis. So that's why this long run analysis it has to be required to access. So for that, we carried out elementary analysis, component elementary analysis, because I should be know that in which component is weird, and this abrasive metal which is collected in the oil sump is weird from which component. So that's why the elementary analysis has been carried out. The main objective of the elementary analysis is to identify the composition of the various metal which is present in the particular component, engine component. This analysis can be served as a guideline to identify the wear of various components at the larger stage. As I said that in the present work, the elementary analysis is carried out for the long run test. Now here, in this table shows that this, 1 minute please. This table shows that this elementary analysis, and it shows that the different elements which are the present in the engine component, suppose manganese, this is a chromium, this is a nickel, ferrous, copper, zinc, manganese, cobalt, lead, aluminum. So the presence of this component in this engine component has been examined. So here this component elementary, again I'll tell you this component elementary analysis. To carry out this component elementary analysis, we have prepared a slide. We have purchased these engine components. We have cut the engine component slightly, and we have tested that engine components. And on the base of that, we received this data that this chromium is present in this percentage. After the elementary analysis, now we aware it that by ये component के अंदर ये element मेरा presence है. So then after we carried out initially wear analysis, weight and dimension. As I said earlier, that weight analysis has been measured in the weighing machine at our institutions, and dimension analysis has been carried out on this coordinate measuring machine at Central Institute of Plastics, CPAT, Ahmedabad. So here in the weight analysis, suppose before the endurance test, if I talk about this component, this is piston assembly. If I talk about this component, so here in the weight analysis, initially it is 669.278 grams, but after the endurance test, what we achieved is that is slightly decreased. If I compare with this one, it is slightly decreased, but the decrement in the B20A4 is not that much compared with, it is some lower compared with the diesel. So we can say that yes, the rate of wear in biodiesel is less compared with the diesel. And again, it is, if I talk about in the range of percentage, it is 7.1% lower compared to the diesel fuel. So Again, there is two dimension that is we have been measured with respect to the diameter, with respect to the x-axis, with respect to the y-axis for the piston assembly. And again, same that we observe that 52.7% is reduction. This is lower wear in B20A4. This is the initial part. This is the initial part of life cycle. There are 3, 4, 5 different stages, and on the base of these different stages, we can conclude that the wear. I cannot directly say that this because of the reduction that wear is not occurs in this B20A4, but there is a supportive process. That one that is a elementary analysis, then the dimension analysis, then the weight analysis, then the physical inspection, then this microscopic image inspection, then the this roughness analysis, then we go furthermore the Lubel analysis. On that basis, we can conclude that yes, this is what at the end of this whole process we can say that the dimension of this engine components. This is a piston assembly. This is a cylinder bore liner diameter. That is again, when you disassemble these all parts at the end of the life cycle analysis, you should have to check this condition, that is burning is occurs or pitting is occurs or erosion is there, sketches is there or not, wrapping is there or not. So this is all part we observe, then we have taken care of the dimension and width, and we observe that again it is a support that the wear in biodiesel with oxygenated fuel is less compared with the diesel fuel. Friends, again, if you see, this is a connecting road geometry. In connecting road geometry, there are two diameter with respect to the C and D, with respect to the two different directions, X and Y axis. We observed, we found it. Again, there is a support that this reduction, excessive reduction that we achieved in connecting road with respect to the diesel in biodiesel. This is what in this wall geometry, in piston ring geometry, this is a piston ring that is radial wall thickness. This is the radial wall thickness. This is a ring gap, and this is this edge. It shows that this is the actual width. So you are in all three parts. The important part that is this gap. This is radial thickness and axial thickness. This is what we observe that again on the weight and dimension analysis, that it is a supportive that the wear is occurred in diesel is more compared with the biodiesel. So this is the one part that we have concluded, that on the basis of dimension and wear, the percentage of wear is higher in diesel compared with the biodiesel. Now the second portion, that is a physical inspection. Now in the physical inspection, if you see in the physical inspection, this is a fuel indicator. This is a before endurance. We have taken the picture at the before the start of endurance for both the engine. This is a diesel and this is a B20E4. Now here in this portion, physically it can be observed that in this tip of the nozzle there is a carbon deposition. Now this carbon deposition, again it is an indication that this carbon deposition may lead to abnormal combustion. While here there is some portion, white portion, as in the cylinder head, this white portion, it shows that there is oxidation. As I said that in the diesel there is a presence of oxidation amount, so there may be oxidation, but there is a excessive carbon deposition on cylinder head after 512 hours. So on that part we say that there is a abnormal combustion, possibilities of abnormal combustion is there in this cylinder head. Same way for the piston, same way for the piston skirt. Piston skirt is highly rubbed when we have disassemble this portion, so it is highly rubbed. But in B20A, for the condition of the piston skirt, it is observed, it is exclusively compared with the diesel, it is fine. Same, sorry, same way for the phase value, same way wall phase, same way for the wall sting. Now, the second portion, as I said, that on the basis of dimension, on the basis of weight, and on the basis of physical inspection, again I say that this wear is less compared with the fossil fuel. Now the fourth portion that we carried out, that is the surface roughness and microscopic close image analysis. It is a qualitative analysis. So here what we have done is, initially we have identified the point on the piston top, in the nozzle top, on the inlet valve. On that particular top point, we have been carried out the microscopic image before endurance, after endurance, and roughness value before endurance and after endurance. So again, it is a 50 magnification and 1000 magnification. So for particular this point, if you observe that this 50% magnification and 1000% magnification, this roughness, there is a scrubbing is there on this surface, and it support the roughness value, average roughness value, and roughness RQ values. So when you compare this diesel value with B20A4, so again there is a reduction in surface roughness with respect to the diesel. So again I say that there is a supportive part. I received that during the surface roughness and microscopic image analysis, they suggest that this wear is occurred in the diesel engine compared with the B20A4. The rate of wear is marginal. I'll tell you, you will not achieve the rate of wear that much that I can achieved, but it occurs. For the long run, 1 lakh kilometer, it will affect. Same with the roughness plot for the 8 mm length, we have observed, and again in the diesel portion, the roughness plot, it says that there is an excessive wear occurs in the diesel engine. Same way for these 8 components we have carried out: exhaust valve, cylinder head, crank subbearing, and cylinder liner for the particular points. And on these all basis, we conclude that this wear is occurred, excessive wear is occurred in diesel compared with the biodiesel. Now, after this qualitative and qualitative analysis, we carried out, as I said, that every 128 hours, we have collected the sample, lube oil sample, and on the lube oil center, we carried out 2 analyses. One is atomic epsilon spectroscopy, and second is ferrography analysis. Now I'll tell you, atomic epsilon spectroscopy, it is generally carried out on AAS analyzer. It is available in the market and in laboratories, Agilent model, and basically it works on the principle of absorption interface, where atoms are in the form of vapor of radiation, absorb radiation energy at a particular wavelength that are perfectly well defined and provide the features and characteristics at a specific atomic metal or not atomic metal. So here we have prepared a slide and we have prepared a slide of lube oil and we have assessed in the atomic epsilon spectroscopy. So that atomic epsilon spectroscopy, around 10 gram of lube oil is taken and weighted at a silica cubicell. Then after it is burned for the temperature of, for the 4 hour, it was been burned for the 450 degree. This is the procedure for AAS. And then for the next 2 hours, it is for the 650. The temperature is slightly increased for the 200 degree for the 2 hours. And then we add a cronk HCl and the mixture is diluted. The addition of diluted mixture then been passed through a air acetylene frame, and then on the basis of this amount of radiation absorbed by the sample used to identify the concentration of various debris metal. So on the basis of that radiation, this identify this which metal, which element is present in the lube oil. So on that basis, we carried out this atomic epsilon spectroscopy. Here, this 8 metal has been presented in front of you. This is a one minute. This 8 metal is presented here. This is cobalt, manganese, lead, chromium. So here again there is a question that it is in the ppm. When you observe with particular interval of 128 hours, it is a time interval particular 8 hours, and it is a ppm for this particular debris metal. So this plot, it shows that for the diesel component, this plot it shows that for the B20A plot, it is gradually, while observing this graph, we can say that it is gradually increased by the time interval, but in the same amount almost. While here in manganese, initially for the 128 hours, it increased drastically. Then it's constantly, it will be weird. So when I compare this, when we compare this both the metal, you can say that in B20A4 the percentage of wear is comparatively low with respect to the diesel fuel. Same way for this ferrous, same way for this copper, zinc, and aluminum. So on this basic, we can conclude again that yeah, there is a rate of wear is higher in diesel fuel compared with the use of B20A4. Again, for this, one more analysis has been carried out because we have to check the lube oil property. It play a key role in the combustion. So lube oil property is also not deteriorating during the 512 hours at the full load condition. Again, we are getting a better combustions at the P theta. We have observed this combustion properties, and we have observed this kinematic viscosity and density during this whole experimentation, and we conclude that yeah, this lube oil, if it happens, if lube oil property is deteriorating with compared to the diesel, then again we are zero. So lubile property is also, again, it is not deteriorating. So we further go ahead and we carried out this ferrography analysis. This is what the last component in our experimentation. So in ferrography analysis, again, you have searched it, you have not received too much material literature on the ferrography analysis, and we have defined one process for the ferrography analysis. It is a really a powerful tool to diagnose this oil properties, oil analysis. For performing this ferrography, the solid abrasive matter, ferrography means कि आपका जो सैंपल आपने लिया हुआ है, ऑयल सैंपल जो लिया हुआ है, इसके अंदर आपकी मैक्सिमम लेंथ, मिनिमम लेंथ का कोई कंपोनेंट है, तो ऑन दैट बेस यू कैन से इसके अंदर स्क्रबिंग बहुत ज्यादा हो रही है, ये कंपोनेंट के अंदर वियर बहुत ज्यादा हो रहा है. सो दैट वी हैव आइडेंटिफाइड द साइज ऑफ दिस डेब्रिसिस मैटर इन फेरोग्राफी, and we observe in diesel and B20 the largest slide particular that is available in this one, it is very high compared with this B20A4. Again, these are every 128. So then at the end of this whole experimentation of qualitative analysis and quantitative analysis, we concluded that this present investigation shows that this B20A4 fuel engine, the wear of vital part are found to be low compared to the diesel engine fuel, and maximum dimension is found to be 60% in case of the cylinder liner and 52.7% in the piston assembly. So this is what we have carried out, and we have concluded that in B20A4 this percentage of wear is less compared with this diesel fuel. Again, this article has been published in the fuel. It is in the elsewhere, that is Tribological assessment in a biodiesel diethyl ether fuel compression ignition engine. And at the last, again, in the same part, we have developed on the regression model. As I said that we have carried out the vibration analysis with the FFT analyzer. We have developed the regression model. The regression model has been developed with respect to these predefined parameters of this engine, this wear analysis, and we have predicted these values, and experimental values almost it is near. So again, this regression model is available in this article, which is available on this open source. For the scope of work, again, this is what the one model that we have been developed, one experiment we have been developed. But again, you can, if you have go for the research work, so again you can change the optional fuel with SI engine, with any biofuel, with or without additives, or by changing engine parameters. You simply take a nozzle spray pattern, you identify this nozzle head number of holes diameters, you change the nozzles, you identify the nozzle patterns, you identify the nozzle spray angles, and then you further go ahead, because ultimately you have to promote this better combustion. Our goal is to give the better combustion, normal combustion, so that automatically the emission will be reduced, the performance will be better. So again, you can go furthermore with the nozzle spray pattern by changing optimization technique. You can change the optimization technique. You can go with the specific engine component. This is piston assembly. And lastly, you can replace, you can keep the engine oil with the same, you can keep the fuel same, and you replace this whole lube oil, and then you check it. Now you go with the experiment on the lubricating oil itself, and you perform this lubricating oil, you go with the life cycle analysis for changing the lubricating oil, so you'll get the better results. So these all are the areas where further you can go for the research, and you go ahead with these directions. Thank you. Thank you, friends. This is what from my end. This is is open if you have any doubts.
Any questions from participants may rise to expert speaker. If any questions having from participant side.
There are few questions in chat box, Professor Reyes.
Yeah, Mr. Unikrishnan, what he said that, wait 1 minute. Whether the interactive effort of CRP has to be simulated first, those software, and then optimal has to be taken expedition optimization. Yes, sir. What he said, Mr. Unikrishnan, very good morning, sir. Whether this interactive effect of compression ratio, injection pressure, injection timing has to be simulated first, though the software, then the optimal one to be taken up for the experimentation optimization. So before that, we have, as I said that earlier, that we have taken the range of compression ratio, injection pressure, injection timing, and then we have defined this design of experiment. On that design of experiment, there is no need. as you said that first, before the simulating with this interactive effect has to be. So first, software itself is give. Software itself is give this interactive effect, and interactive effect of the CR, IP, and PT has to be correlated with our experimentation. So why this compression ratio is in, why the advancement of compression ratio and advancement of injection pressure, why this brake thermal efficiency is increased. This is what the correlation has been done after this simulation of the software. During the weight analysis, durability, whether the carbon accumulation on the piston ground and development on the underground during the weight analysis. Sir, I'll tell you first thing that before we carried out the weight analysis, later on we carried out the weight analysis. After removing this all carbon accumulation on the piston ground, we have cleared this piston ground, because ultimately then we will not get the better exact weight part. So we have cleaned this whole parts, and then we have been taken the weights. Thank you, sir. Yeah. Yes, professor.
Yes, any questions from participants? Otherwise, we conclude this session.
It is really great for, it is really after a long time in administration, it is really, and the mass, more than 60 people are associated with this FDP right now, connected right now. So again, it is really, I'm very thankful to the ADIT families and all the participants. It is really great pleasure for me to be a part of your faculty development program.
So, sir, we are going to conclude the sessions, and we are happy to see you, sir, on this platform after a long time. And thank you so much, sir, for your wonderful presentation on tribological assessment of CI engine fuel with biofuels. And as utilized at certain level in CI engine, but many researchers are still research on biofuel for better use and result, as you have said in several.
Again, I'll tell you, this life cycle for the SI engine, you will get the limited literatures on the literatures. If you search for this SI engine, again, life cycle for this SI engine, liquid fuel and gaseous fuel, you will get less literature. So these all are the research gap where we can go further more, and we can go for the research, and we can, our goal is to establish the potentiality as an alternative fuel in CI engine. So there are, furthermore, it is required to be examined. Thank you, sir.
There is a much scope is still available for researchers, and it is really impressive for all of us to see the practice of biodiesel use, which you have mentioned. So once again, on behalf of ADIT, Automobile and Mechanical Engineering Department, I would like to thank you so much, sir, for accepting our invitation and spend your valuable time.
It's a pleasure to be a part of your FDP. I am thankful to the ADIT family and head of the department specifically.
If I can add something, Dr. Paresh.
Yes, sir.
Yeah. So for participants, let me tell you that despite of being, he's a very good speaker and he's a very good human being, right? We have continuous interaction with him. He accepted the invitation and he presented all his research work very nicely. So I hope the participants would have got, really this was informative session, right? So again and again, we would like to interact with you in future. So,
definitely, sir. I'm eager to see you again.
Yeah. So again, on behalf of all, I would like to thank you. Thanks.
Thank you, sir. May I leave, sir?
Yeah, please.
Thank you, sir.
Thanks.
Thank you, sir. Thank you, sir.
Thank you.
Thanks to all.
Thank you. So, yeah, Professor Ernest.